Are live. Yes. Hello, hello, everybody. Welcome to tonight's live. I am Robert, the AP Math Guy, and tonight we're gonna be going a little bit. We're gonna diverge off the path a little bit, but we'll be back on that tomorrow. But tonight, because I wanted to do something fun, I wanted to go over something that I didn't go over on my first run through up to this point, and that was hyperbolic trig derivatives. Now, these aren't going to appear in AP Calculus A, B, or BC, and some teachers in college don't even go over these. But I figured tonight, why not? So yeah, welcome everyone. Hopefully everyone had a good Sunday. Um, hey EJ, how's it going? I have to admit, I my Patriots lost today. 6 turnovers. Had a very good game. That was a very winnable game against Pittsburgh, but it is what it is. There's always next week. Um yeah. So go ahead and do a quick mad tap. See if we can't get to 500 likes before we get started. Also, the other piece of news I wanted to share with you all that I think you'll like. Hey, Mark, how's it going? So, at this point, every single live that I have done thus far in this second round of calculus is now uploaded here. Oops, that is my tire pressure gauge. I don't know what that's doing here. But yeah, so now if you go here and you go to this channel, you'll be able to see every single live that I've done so far. Or at least the ones that the most up to date ones. I think they go as far back as early August. Hi Isabella, how's it going? How is it going? We are already past 500 likes. So way to go, everyone. So yeah, hopefully I don't know what team I don't know if you root for any teams you root for, but I hope they won. Should I do my calc homework tomorrow or avoid it another day? What's your calc homework on? What is your calc homework on, Isabella? Either way, you should do it tomorrow, but just because I'm curious. I had to check. I think something with intro to limits or in logarithms or something. Okay, integration by parts. So actually, that's the other thing I wanted to show you all. So, in my quest to clean up my space and get rid of unnecessary note cards, I have converted my topic request list the from 2 note cards to this one notebook. So I'm starting to make this list, and eventually I'd like to narrow it down. But we are still, some of these topics I could go over. I'll probably be going over sooner rather than later, and others are going to have to wait a few weeks. But as soon as we do a topic like for example, this this I plan on doing sometime this week. Um, let's see, what else could I theoretically get done this week? I could do that this week. Oh, here's the other thing. Next week I will be announcing a second live. Um, and so some of these topics may also be may also appear on that second live. I don't know a time yet, but that's why I'm waiting till next week to announce it. So that way, because I have a couple of I have one more student right now that I need to get their schedule settled. But as soon as I do, we will be having a second live. All right, so I know I saw a few comments as I was talking, so let me go ahead and go back a little bit. Tangent planes and linear approximation. Do I have that already? If not, that will be another thing that I have to add. Linear approximation I'm going to be doing soon. So that I could probably knock out either this week or next. Tangent planes, that would be Calc 3, which is going to be a little while. So I'll add those two to the list. So, tangent planes, not trig planes. Tangent planes. And you said linear approximation as well. So, linear approximation. So yeah, I plan on getting to this at some point too. Probably this week. Haid Laplace transform, and yeah, those two are kind of difficult. Physical application. Do I have any lives this week? Yeah, so I go live every single night at 11:30 p.m. Or at least I try to. All fantastic topics. I agree. You wanted to go over Taylor series. I think I have that already. Yeah, I do. How often and what time are your lives typically? I love all of these topics. Sure, Em. So I go live every night at 11:30 p.m. Eastern time. Thank you, Blake, for the follow. We are, as far as I know, we are officially 18 away till 1700. My goal is to get to 2K by the end of a month, so I need to average about 32 followers a night to do that. But I think we can do it. Oh, thank you for the heart me living my life. Sorry about that. I did see that and I was going to acknowledge it. Hyperbolic trig about to get some e to the x. Yes. So I think thank you Cleopatra for sharing the live. Are you a mathematician? What is your background or specific area of expertise? If so, I am actually not a mathematician. I am just a humble math tutor. Though one day I might go for my master's in math, but right now I only have a bachelor's, and that bachelor's is about 10 years old, little more. Wow, hard to believe it's been 10 years since I graduated college. That's crazy. But yeah. Cool. So, let's go ahead and get started. I wrote myself... It's been a while since I've done hyperbolic trig functions, so I had to write myself down a few notes, but I think I got them. So, who's Cody? Great job keeping up your knowledge and spreading it with others. The best gift to... Absolutely. Thank you, Em. I remember, and I think it was Einstein that said this, but I'm not positive. But I think he said one time that the best way to understand something is to teach it to others. And so that's my goal, right? I want to teach you all this math and show you that it's not as scary as it seems. Because just like the Transformers, it's more than meets the eye. We could see a problem and it looks scary when it actually isn't. So yeah. So with that, let's go ahead and get started. Hey Math Tutor, how's it going? Welcome on in. So, can everyone see the notebook all right? I'm just gonna do a quick focus. Right. Here we go. Can everyone see that all right? I wish I had something like up here that would cover that blank space, but you know what? Let's do this actually. There we go. That's better. Awesome. Cool. How did I like your proof? Was it the one about the square root of x squared equaling x? Also, thank you for the heart me, Math Tutor. Yes. Okay. So I did like it. I'm going to I'll I'll talk to you more about it over chat, over a direct message. Thank you for the follow. Unfortunately, it's blank, so I can't acknowledge whoever just followed me, but thank you. Cool. Alright, so let's go over hyperbolic trig. So, we know the 6 basic trig functions, right? We have sine x, cosine x, tan x, and we have, then we have cosecant, secant, and cotangent. Thank you, EJ, for the rose. So, here are our 6 basic trig functions. And what we know about them is that they relate to a circle. I had my unit circle here a little while ago. Oh, nope, that's not it. Huh. Watch, in about 10 minutes when I don't need it, it'll be like, hey, here I am. Anyway, so all 6 of these are related to a circle. But we're not going to talk about these tonight. Instead, we're going to be talking about what's called a hyperbolic trig. The main difference between our regular trig functions and our hyperbolic trig functions is that instead of a circle, we use a hyperbola. A hyperbola is a really cool looking function. Let me show you what a hyperbola looks like. So let's say that I have a graph. I'm going to try my best to draw this, but I'm going to warn you in advance that, again, for those of you who have been here a while, you know that I'm not the best drawer on the planet, so I'm going to give it my best, but here goes nothing. So a hyperbola looks kind of like this. So I'm going to draw a dotted line here. I'm going to draw a dotted line here. A hyperbola looks like this. Now, one thing I wasn't taught when I was in high school were these things called conic sections, which is if I take a cone and I slice it with a plane and open its cross section, there are four pieces to a there are four conic sections. There's a parabola, there's a hyperbola, which looks like this, there's an ellipse, and there's a circle. This is one of the conic sections that we're going to use, and it's the one we're going to use tonight. So to signify that I'm using a hyperbolic trig function, what I'm going to do is I'm going to write my regular trig function, like sine, and instead of putting an x immediately next to it, I'm going to put an h right next to it, followed by the x. This h automatically tells me that this is hyperbolic sine of x. Likewise, I have hyperbolic cosine, hyperbolic tangent, then I have hyperbolic cosecant, and then I have hyperbolic secant, and hyperbolic cotangent. Now, we have to define what these functions mean. So, I'm going to define sine and cosine because the rest follow from those two. So, I'm going to go ahead and give you the formal definition of sine, hyperbolic sine and hyperbolic cosine. So hyperbolic sine is equal to e to the x minus e to the negative x all over 2. Conic sections killed me in pre-cal. Yeah, I don't know why we never learned about conic sections in any class. I thought that was kind of weird. And then hyperbolic cosine is going to be the same as this, except for this sign. Instead of negative, it's going to be a positive. So it's going to be e to the x plus e to the negative x all over 2. I have plenty of videos on conic sections in my content. That's cool, Math Tutor. That's really cool. So, these are the formal definitions of hyperbolic sine and hyperbolic cosine. Thank you, Daniel, for the follow. So now, just like regular trig, tan is going to be sine, hyperbolic sine over hyperbolic cosine. Thank you, ICHNDC1, for the follow. Cosecant is going to be 1 over hyperbolic sine. Secant is going to be 1 over cosine, hyperbolic cosine. And cotangent is going to be hyperbolic cosine over hyperbolic sine. And don't worry, I'm going to write this on a note card so that way we don't have to try and read all of these. So, now, hey Brandsy, how's it going? Do I teach Calc 2? I tutor Calc 2, yes. Your show is on? What am I teaching today? Today, we are going over hyperbolic trig derivatives. Something a little different. And something that you're most likely not going to see in your AP Calculus class. In fact, I'm pretty sure they don't teach this in AP Calc, either AB or BC. But sometimes in Calc 1 or Calc 2, your teacher will teach this, so figure it would be kind of cool to see. So that is what we are doing today, Brandsy. So now, let's go ahead. Now that I have my definitions, let's go over derivatives. So first, I want to take d dx. So d dx of hyperbolic sine. Well, as we see here, hyperbolic sine is equal to this right here. So I'm going to write that up there. So I want to take d dx of my definition, which is e to the x minus e to the negative x all over 2. Nice, I'm restudying vectors in 3 dimensions. That's awesome. That's really cool, ICH. That is really cool. So, here's what I'm going to do. First, before we continue, do we agree that if I have 2 things being subtracted over a single denominator, I can split the 2 fractions? Can power rule be applied here? I'm new to calculus. So e to the x is its own special derivative that we're going to get to in just a moment. Rafa says yes. So, for example, if I had, say, I'm going to do some scratch work over here. Say if I had x minus y over 2, I could split that as x over 2 minus y over 2. Do we agree or disagree on this? ICH says yes, for sure agree. Rafa says yes, you can. Awesome. So, what I'm going to do we also agree that if I have, say, x over 2, I can rewrite that as 1/2 x? So do we agree on this premise? I'm just making a general case. I'm not referring to this specifically. I'm just making a general case, Rafa. But even then, even in this example, x over 2 would still be positive. If I did y over 2, then absolutely it would be negative. But here, x over 2 is positive. Well, at least the 1/2 is positive. We don't know what x is, but x can be any number. So we also agree on this? Yes? Awesome. We do agree. So, I'm going to apply this over here. So, I'm going to take d dx of 1/2 e to the x minus 1/2 e to the negative x. I didn't traditionally tutor math, so this is informative for me tutoring math moving forward. Awesome. Awesome, IR. I'm glad. I'm helping you. So, here's what I'm going to do. Now, I'm ready to take my derivative. So remember the rule about e to the x. What is the rule about e to the x? Well, e to the x is a special derivative in that if I take d dx of e to the x, then its derivative is e to the x. So here, this is going to be 1/2 times e to the x. Well, remember, e to the x is its own derivative, and I have a constant times this function, so the 1/2 is going to stay where it is. So this is going to be 1/2 e to the x. And now, what's the derivative of negative 1/2 times e to the negative x? What do you think? This one's a little tricky. What do we think what do we think that derivative's going to be? Almost. There's one difference. That's right, GM. It would be positive. Why? Because I would use chain rule. So chain rule says that if I have a function trapped in another function, if I have function trapped inside another function, I take the derivative of the outside, leaving the inside alone, and then I multiply by the derivative of the inner function. So it's kind of hard to see, but I can write e to the negative x as e with parentheses around the negative x. So e to the bottle cap, negative 1/2 e to the bottle cap is negative 1/2 e to the bottle cap times the derivative of what's underneath the bottle cap. What's underneath the bottle cap? It's negative x. So I have negative x here. And then the derivative of negative x is negative 1. So negative 1 times negative 1/2 gives me plus. So now, I think we can also agree that I can go from here to here, yes? I can go either way. Thanks, Sam, for sharing the live. Sorry, caught something in my throat there for a second. Anyway, so, because of this fact that we agreed to a little bit ago, and because of this fact that we agreed to a couple minutes ago, I can rewrite this as e to the x over 2 plus e to the negative x over 2. And then because of this fact, I can then rewrite that as e to the x plus e to the negative x all over 2. Now, hold on a moment. Have we seen this before? Have we seen e to the x plus e to the negative x all over 2 before? That's right, M. It's going to be hyperbolic cosine right there. So e to the x plus e to the negative x all over 2 is hyperbolic cosine. That's what we have here. So this is hyperbolic cosine. So d dx, therefore, d dx of hyperbolic sine is simply hyperbolic cosine. Kind of cool, isn't it? Awesome. So, now we've discovered one derivative. Now let's go the other way. Let's find the derivative of hyperbolic cosine. So, d dx of hyperbolic cosine. Well, again, I can find d dx of e to the x plus e to the negative x all over 2. And that's by definition of hyperbolic cosine. So again, hey Felicia, how's it going? Welcome on in. So again, we agree on this fact. Do we also agree that it doesn't matter whether I put a plus or a minus here, this fact will still be true? ICH says yes. Thank you, Amlin, for the follow. Do we have agreement? You got a 61 on your Calc 2 exam? Okay. Hey, you know what? You you almost passed. And a 61 and a 60, you can come back from a 61. Thank you, Jackson, for sharing the live. So yeah, we agree that whether this is plus or minus, this fact still holds. Of course, this sign would change from negative to positive if we were adding here, but we agree that so long as these two signs match, this is true. So let's apply that fact here. So I'm going to find d dx of 1/2 e to the x plus 1/2 e to the negative x. We've already found the derivative of 1/2 e to the x, so I'm not going to make you do that again. This would be 1/2 e to the x. And then what's the derivative of 1/2 e to the negative x? Thank you, Buff Bearded, for the follow. So what is the derivative of 1/2 e to the negative x? What do we think? You're right, ICH. That is exactly right. The derivative is going to be negative 1/2 e to the negative x. Very good. Very good, Felicia. Yes. So, now that I have this, I can use these two facts again. So this is going to be, thank you, Big Ox, for the follow. So this is going to be e to the x minus e to the negative x all over 2. Wait a minute. Have we seen this before? Do I do Calc 2 ever? Yeah, I'm going to be starting Calc 2, I think sometime in early October. I don't think there's much left in Calc 1 that I'm going to be going over. I think it's going to be a week or 2 max before I get to Calc 2, but I'm almost there. That's right, Felicia. That is exactly right. This is hyperbolic sine. So we've learned that d dx of hyperbolic cosine is equal to sine hyperbolic sine of x. Now here's the thing I want you to notice. What's the derivative of cosine? What's the derivative of regular cosine? Right, Felicia, it's negative sine. But if you notice, the derivative of hyperbolic cosine is positive hyperbolic sine. That's interesting. Or at least I think it's interesting. Does the derivative of hyperbolic cosine over a derivative of hyperbolic sine equal tan? So hyperbolic cosine over hyperbolic sine is cotangent. Other way around will give me tangent. So, but here's what I want you to notice. Derivative of sine is cosine. Derivative of cosine is sine. Or negative sine. Not positive sine, negative sine. What math is this? This is calculus. So, derivative of hyperbolic sine is hyperbolic cosine. and the derivative of hyperbolic cosine is sine. So, I don't remember doing this in Calc 1. Yeah, so this doesn't appear at all in the AP curriculum. And some teachers don't even teach this. But I figured it was a cool thing to look at. I do agree, Felicia, that is right. But, what is the derivative of regular tangent? I'm struggling in trig right now. This looks insane. Okay, Jacoby, believe it or not, okay, Oh, you learned this in Calc 2. So I guess we are doing some Calc 2 tonight. For whoever said that, I ever do Calc 2? But yeah, I'm struggling in trig right now. This looks insane. Okay. What are you learning in trig right now? Inverse trig functions? Okay. So I actually, believe it or not, I just did a live on could you explain geometrically why those are the definitions for each trig function derived from? Are you talking about like these? I love calculus. I do too, Aiden. I missed math. Well, welcome back. The hyperbolic trig functions. I assume you're talking about these. I've taken Calc 1, 2, 3, or ODEs and PDEs, and I've never once dealt with hyperbolic trig. Okay. And like I said, not every teacher is going to go over hyperbolic trig, but it's cool to know, I think. Thank you, user, for the follow. Or should I say user wolf for the follow? Yeah. Yeah, once you get these two, the rest fall naturally. Yes, where are they derived from geometrically and what causes that type of symmetry? So hyperbolic functions are what we call conic, one of the conic sections. So essentially, imagine taking a cone, or I think this is the result of taking one cone. So I'm going to attempt to draw this. So I'm going to do. I'm not the best drawer in the world. So but here goes nothing. So suppose I have a cone. I think hyperbolas come from two cones, one stacked on top of the other. And I have a plane, and I cut through the cone, and I open it up to see its cross section. So there are four conic sections that I can have: either circles, ellipses, or ellipses. I don't exactly know how to pronounce it. Parabolas, and hyperbolas. Just like we have trig functions for a circle, we have trig functions for hyperbolas, and that's where these come from. The rules of trig still mostly follow, but we define sine differently than we defined hyperbolic sine and cosine differently for hyperbolas than we do circles. Once calculus clicks, it really becomes easy. It takes a lot of practice. I agree. And the other thing that makes calculus easier is if you have a solid algebra and trigonometric background. So, I've heard it said before that the hardest part of calculus isn't calculus. The hardest part of calculus is algebra. The calculus just adds a tiny bit of complexity. but it's just algebra. Hmm. So a lot of the the hyperbolic trig is a result of the exponential functions. Um, Help. Oh, what do you need help with? Everything okay? So I'm going to So there's a It would take me a while to explain where the hyperbolic functions come from. So I'm going to okay. I think I understand somewhat. Um so where we look at so so hmm I think so when we look at circles, like if I have my unit circle, which I'm going to try and find here, but the unit circle, oh, here it is. So here, in order to figure out its degree measure, I'm just taking essentially the measurement of its arc on the circle. Whereas with hyperbolic trig, we're not looking so much at the arc length, we're looking at the area of the sector. And like I said, I could make a different video on hyperbolic trig, on the explanation behind hyperbolic trig. Yeah, don't be sorry. Don't be sorry at all, Em. Do not be. Please do not apologize about asking questions. Questions are awesome. All right, so in the interest of time, audio is in and out a lot. Okay, can you hear me now? Is it better? Testing 1 2. Testing 1 2 3. It might be muting when no sound. Interesting. I'm not sure. Like, can you hear? Like, if I keep talking for a few seconds, I just want you to tell me if you can hear me or not. Um, so anyway, when it comes to You can hear me? Perfect. Yeah, what I think happened is that I stood up to grab my unit circle from my on top of my printer, and so I might have moved away from the mic for a moment, and that might have been what caused the audio to go out. Because as far as I know, so I use a document camera to record this, but there's also a mic I believe attached to that document camera, so it might, and the range of it's not very good. Like I could, like the cat could be right behind me, and you probably wouldn't hear him unless he's on my desk. Like like if like if something were to fall behind me, you probably wouldn't be able to hear it. Um, I'm wondering about looking into maybe getting a microphone, an external microphone. But for now, yes, I will look into the derivation for myself. Thanks for piquing my interest back to solve. No problem, ma'am. No problem at all. And like I said, unfortunately, I don't know the answers to every question. But I'll look into it as well because I'm really interested now in seeing if I can give you a better explanation. But anyway, back to taking derivatives. So, for the interest of time, I'm going to go ahead and give you the other four trig derivatives, or hyperbolic trig derivatives. But what if I told you you already knew what they were? What if I told you that you already knew what the last four trig derivatives were, for the most part, or hyperbolic trig derivatives? Like, what if I told you you already knew the derivative of hyperbolic tangent? You would believe me? Okay. Do we have any? Is there anyone in here that doesn't? And it's okay if you don't. It is perfectly okay if you don't agree with me. I'm about to have an exam tomorrow with Calc 2. Okay. Good luck. Good luck, double. On a scale of 1 to 10, how are you feeling about the exam? Not too great. Inverse and hyperbolic are gonna get me 6 out of 10. Okay. So you are working with these. Interesting. Are you taking pre-calc? You have to do Laplace transforms tomorrow. Oh boy. Is it a quiz or are you learning about them? Is this Calc 2 or 3? So the book that I got this says this is Calc 1, but I've seen this in Calc 2 before. Yeah, I would say more than likely this is Calc 2. Are we going to see this again for a little while? Probably not. But I figure tonight's a good night to show you this because I think it's kind of cool. And sometimes that's how we determine sometimes that's how I determine what I present, whether it's kind of cool, whether I think it would be cool or not. What's the h on the trig functions? So that's a good question, Stripe. So tonight we're talking about these things called hyperbolic trig derivatives. So the h in front of the on the trig functions symbolizes that it's not regular cosine or regular sine, it's hyperbolic cosine or hyperbolic sine or hyperbolic tangent. Test tomorrow, but it's not for a math class. I'm just rusty with Laplace part. Okay. Well, at least it's not a test. Thank you, Ron, for the follow. So cool. Back to this. What if I told, is there any, so let me ask you a question. What's the derivative of tangent? If I were to ask you derivative of tangent, what would you tell me? Secant squared, right, Em? Secant squared, right, Felicia? So, just like regular tangent, the derivative of negative, or not negative. Let me try it again. The derivative of regular tangent is secant squared. Nope, not plus c, where you wouldn't be integrating. Just like the derivative of tan is secant squared, the derivative of hyperbolic tan is hyperbolic secant squared. Although I think the h actually goes here. Nope, it would be positive. It is positive secant squared. Hyperbolic secant squared. Yeah, no problem. Actually, I have to include h here. Alright, so what is the derivative of cosecant of x? You got a math degree? I do indeed. I have a bachelor's in mathematics. Close. It's not sine. So remember, the derivative of cosecant, it is negative, that's right. Oh, yeah, no problem. No problem, yo mama. No problem at all. So, derivative of cosecant, that's absolutely right, Felicia. So the derivative of cosecant is negative cosecant x cotangent x. So just like that, the derivative of hyperbolic cosecant is negative hyperbolic cosecant times hyperbolic cotangent. Wait, what's the difference between regular derivatives and hyperbolic derivatives? So I agree, Felicia. It's not much, but the only difference between, in this case, regular trig derivatives and hyperbolic trig derivatives is that hyperbolic trig comes from hyperbola versus regular trig, which comes from a circle. Right, exactly. And then, just like the derivative of secant is secant tan, the derivative of hyperbolic secant, and here's where the major difference, here's where the difference comes in. The derivative would be this, but for reciprocals, it would be negative. So remember how with regular trig derivatives, any of the three functions that begins with a c is its derivative is negative, whereas here, any of the reciprocals of sine, cosine, or tangent have negative derivatives. Thank you, DIY, for the follow. Is this all I go over, or do I get into different topics? So right now we're exploring calculus, but eventually I do plan on getting into other forms of math. Yeah. I'm in Calc 3, that's why. Okay. So when do I think I'm gonna get into Calc 3? I don't have my plan in front of me, but I think we're getting into Calc 3, if I had to guess, probably sometime either in December or January, but I'm not sure. Again, it could be sooner, it could be later, but that's, if I had to guess, that's where I think we're going to be, when we're going to go there. So yeah, and then just like the derivative of cotangent is negative cosecant squared, the derivative of hyperbolic cotangent is negative hyperbolic cosine, not cosine, cosecant squared. Thank you, Yo Mama. Thank you so much. All right, so let's go ahead and try a couple different problems involving our rules. But before I do that, let me go ahead and write them down on a note card so we don't forget. Because I'm going to turn the page here in a moment, and I don't want to go back and forth. So let me go ahead and write them down quickly. And while I write these down, let's go ahead and do a quick mad tap. So ddx of hyperbolic sine is hyperbolic cosine. Derivative of hyperbolic cosine is hyperbolic sine. The derivative of hyperbolic tan is hyperbolic secant squared. Thank you, BBB, for the follow. And then, on the other side, we'll have ddx of cosecant, or hyperbolic cosecant, is going to be negative hyperbolic cosecant, hyperbolic cotangent, and then derivative of hyperbolic secant is negative hyperbolic secant times tan, hyperbolic tan. And finally, hyperbolic cotangent is negative hyperbolic cosecant squared. This calc or trig? This is calculus. Only one of these questions was on my exam. It was hyperbolic sine of 2x plus hyperbolic secant of 2x, but we never learned that. Okay. Interesting. So now that we have our derivatives noted, I'm going to go ahead and turn the page. I like this more than having to turn the page vertically. So let's go ahead and try a few exercises involving our hyperbolic trig. So first, let's start with the following. So example, if f of x equals 2 times the hyperbolic sine of x plus 8 times the hyperbolic cosine of x, what is f prime? So now, let's go ahead, and so here, I have a constant times a function, so that means the constant's going to join the derivative. What's the derivative of hyperbolic sine? let's factor out 2 sine. We could, but there's no if I'm just finding the derivative, then then it would kind of be a moot point. Felicia says 2 cos x plus h hyperbolic sine of x. Yeah, that's exactly right. Why? Because the derivative of hyperbolic sine is going to be hyperbolic cosine. And then I have an 8. Thank you, Apple user, for the follow. And then I have 8 times the derivative of hyperbolic cosine, which is sine. Hyperbolic sine. And that's it. That is it. Let's try another one. Let's try f of x. If f of x is equal to 3 hyperbolic tan minus 4 cotangent, hyperbolic cotangent of x. What would that derivative be? Easy work, okay. Let's see. What would my answer be? What would the derivative be? Felicia says 3 hyperbolic secant squared plus cosecant hyperbolic cosecant squared. You're almost there, Felicia. Yes, that's right. I was gonna say you forgot something. So here, constant means it joins the derivative. Derivative of hyperbolic tangent is hyperbolic secant squared minus 4 times the derivative of hyperbolic cotangent, which is negative cosecant hyperbolic cosecant squared. But negative times negative makes this a positive. So this would be plus 4 times hyperbolic cotangent. Cotangent. Let's try that again. 4 hyperbolic cosecant squared of x. And again, that's it. So far, pretty simple, yes? Nothing too bad. Let's go ahead and try some product rule. So, if f of x is equal to sine of x times hyperbolic sine of x. So here, I need to, so I'm going to do product rule. And what does the product rule say? Well, the product rule says that if I have two functions being multiplied together, I take the derivative of the first function and multiply it by the second function, and then I switch their dance partners by taking the derivative of the second function, multiply it by the first function, and add the two products together. So my first function, I'm going to let g of x equal sine of x, and h of x equal hyperbolic sine of x. What is the derivative of sine x? And says hyperbolic cosine. That's the derivative of hyperbolic sine, right? So we got that. What about the derivative of regular sine of x? Right, Ed, it's going to be cosine of x. So now I have everything I need to do product rule. So I'm going to link my functions together. So remember, derivative of the first times the second plus the derivative of the second times the first. So this is going to be f prime of x is equal to sine x times hyperbolic cosine of x plus cosine x times hyperbolic sine. Nope, that's actually a good question. So h is not a variable. The h tells me that this is hyperbolic. If this were a constant, then you'd be absolutely right. But the only thing that's in the parentheses here is the x. I don't think I can combine or simplify, so I'm going to go ahead and say that I am done here. All right. Is that English? I don't know, is it? Love the consistency I see the work you put in. Thank you, Just Thought. Thank you so much, and thank you for the follow. Let's use one with trig identities. So, do I have... Looks... Good one, faded one. That is a good one. So I actually have a few problems prepped already, Stevie. If we do use one with a hyperbolic trig identity, we'll run it. We'll cross that bridge then. But I'm not sure any of them will have that. Do you need double angle formulas memorized for Calc 1? It's not, I'll say this, it's not a bad idea to know them. But for the most part, I agree with Felicia. You're most likely not going to see them that often. But again, it's not a bad thing to know. Yeah, no problem, Stevie. No problem at all. In fact, I think tonight's going to be a shorter live anyway because um like that this is just something I thought that would have been pretty cool to know. But we'll do a couple more problems and then we will call it a night. So, let's see. Hmm. I like that one. So we have 10, or actually, f of x is equal to 10 times hyperbolic tan of x times hyperbolic secant of x. None of this is right, by the way. Okay, where did I go wrong? It's possible I've done stuff wrong, but where did I go wrong? Never mind. Okay, yeah, no, that's perfectly fine. So the h is not a constant, but the only trig things you need memorized for Calc 1 is just the reciprocals and trig identities. For the most part, yeah. Oh yeah, I remember trying to tackle Calc in ninth grade and my brain turned to mush. You took it in ninth grade? That's awesome. I didn't take it till I was a senior in high school. Cool. So, we have another one that involves chain rule. So this 10, I'm going to put with this hyperbolic tangent. So here, I'm going to let g of x be 10 times hyperbolic tan. And I'm going to let h of x equal hyperbolic secant. I took calc until differential equations and I tutored calc 1. Awesome, Tim. That's really cool. So, let's go ahead and find DE was hell. I'll be honest with you. So when I took differential equations, I was a sophomore in college and I had just taken calculus 1 and calculus 2 and I did well in those classes and I thought, if all of college math is going to be this easy, I'm just going to coast right through it. And then I ran into differential equations. Yeah, that was tons of fun. I barely passed, but it taught me a good lesson. Despite that, can you believe I still hate math? I'm sorry to hear that, Tim. Nah, Calc 2 was pure torture. I had to retake that 3 times because my major needed me to get an A. Okay. Calc 2 can't be that bad, can it? It's not the worst math class, but of Calc 1, 2, and 3, it's widely regarded to be the most difficult. But that said, I think you can do it. Agreed. So anyway, What is the derivative of 10 times hyperbolic tangent? Calc 3 is okay if your basics in Calculus 1 are solid. I agree. What level of calc is this? So this is technically Calc 2, but we're taking derivatives, so you're and a lot of teachers don't even teach this stuff. So, but I thought it was kind of cool. Never understood what the point of hyperbolic functions were for back in school. Actually, you take linear algebra is actually really fun. It was the one math class that my college offered for math majors that I did not take. And the only reason I didn't take it was because I was student teaching and I couldn't fit it into the schedule. Is this essentially L'Hopital's in a way? Nope. Two different things. Can you give one example where hyperbolic functions are used in? I could. I think a Google. I think if I could probably do a Google search of applications of hyperbolic functions. What is linear algebra? So linear algebra deals mostly with systems of equations. So, although the difference between what you learned in algebra 1 or 2 and what you learned in linear algebra is instead of having like 2 or 3 variables, you have literally a ton of variables. Thank you, Brissia, for the follow. You're welcome, Brissia. All right, so back to this. So what is the derivative of hyperbolic tangent? I'll give you a hint. It's right on at the bottom, or actually move this up here because I realized the other night that the comments sometimes block from like here down. So I'll move it up here. Felicia says 10 hyperbolic secant squared. Brissia says secant squared. Almost, Brissia. You're missing something though. The derivatives are all the same, just add an h. For the most part, yes, except that the derivative of negative cosine is normally negative sine. So the three main hyperbolic trig functions of sine, cosine, and tangent are all positive, whereas the reciprocals their derivatives are all negative. Linear algebra is the study of vectors and matrices. Yep, that's right. So, yeah, so the derivative is going to be 10 times hyperbolic secant squared. And then what's the derivative of hyperbolic secant? What time is it for me? It is about 1 in the morning. It is 1 in the morning on Monday morning. Yeah, I know, right? So the derivative of hyperbolic secant is negative hyperbolic secant times hyperbolic tan. So this is going to be negative hyperbolic secant times hyperbolic tan. So now from here, I'm going to go ahead and link those two together. So I get derivative of the first function times the second function. So this is going to be f prime is going to be 10 hyperbolic secant squared times hyperbolic secant. So that's going to be 10 hyperbolic secant cubed of x plus, or should I say minus, 10 hyperbolic tangent times negative secant, hyperbolic secant times hyperbolic tan. So this will be 10 hyperbolic secant times hyperbolic tan squared. I don't actually, I could simplify further. I can factor out a 10 secant, hyperbolic secant, 10 hyperbolic secant. I'd be left with hyperbolic secant squared minus hyperbolic tangent squared. I don't think I can go any further, so I will go ahead and call it done. What math do I teach? So I actually tutor a lot of them. In fact, here is a list of every single math subject I currently tutor. Yeah, it is a lot. Surprisingly, though, it's not as much as you would think, right? Because, like, these two are almost the same. Those two are almost the same. And those are the same. So if you combine the underlined ones, I only have like what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is extensive. Yeah. It, like that, it does seem like a lot, but half of them, like, I have 8 classes essentially I've written, 4 classes I've essentially written twice. Just different curriculums. So yeah. Let's do one more, and then we'll call it a night. So, it is time for the final problem. So tonight, there are 11 of us in here. So, in order to get to the final problem, let's see if we can't get to 2.5K likes. So I'm a teacher. I used to be, but I'm a tutor. Yeah. Integral of secant cubed. So trig integrals I have on my list already of things to cover in the future. I think they're here. I could have sworn they were. Trig integrals right there. Thank you, Marcos, for the follow. So this one, I will say for this problem, we're going to do some chain rule. And we'll do a little quotient rule as well. So, oh perfect, we've already hit 2.5K. Let's go. Alright, so f of x is equal to hyperbolic cosecant of natural log times hyperbolic cotangent of natural log all over x. So here, I'm essentially doing three rules. I'm doing product rule up here, I'm doing chain rule twice, and I'm doing quotient rule. So, let's go ahead and break this down a little bit. First, let's go ahead and do product rule on these two. So, I'm going to let g of x equal hyperbolic cosecant of the natural log. And I'm going to let h of x be hyperbolic cotangent of the natural log. So, let's bring out my bottle cap. So let's, instead of finding this derivative, let's find the derivative of this. What is the derivative of hyperbolic cosecant of bottle cap? Derivative of hyperbolic cosecant of bottle cap. Cancel out the natural log? How would it cancel? Oh. I just realized. Oh boy. Oh boy. I just gave you the wrong problem. Oh well. We can go ahead and do this. So the derivative of hyperbolic cosecant of bottle cap is negative hyperbolic cosecant of bottle cap times hyperbolic cotangent of bottle cap times what's underneath the bottle cap is natural log times the derivative of natural log. Well, the derivative of the natural log of x is simply 1 over x. So this would be times 1 over x. Chain rule on in, bro. Okay. And then the derivative of cotangent, hyperbolic cotangent of bottle cap is going to be negative hyperbolic cosecant squared of bottle cap. This would be negative hyperbolic cosecant squared of what's underneath the bottle cap is natural log times 1 over x. So now I will have everything I need to find a derivative. And actually, I'm not sure I'm going to have enough room here. So here goes nothing. If I need to, I'll move the derivative down here. But let's see how this goes. Are we trying to find x? Is this like a puzzle for math? Nope. We're finding the derivative. So f prime. Here we go. So Remember the quotient rule, low d high minus high d low, all over the square of what's below. So this is going to be, I already know that I'm not going to have enough room, so I'm going to write it down here. So f prime of x is equal to x times the derivative of the top. So this is going to be derivative of the first times the second plus the derivative of the second times the first. It is calculus, that's right. Thank you, Jasmine, for the follow. So I have negative hyperbolic cosecant of natural log times hyperbolic cotangent of natural log all over x times a hyperbolic cotangent of natural log. So this is going to be times negative cosecant, or negative hyperbolic cosecant of the natural log so actually I'll put this in parentheses, times cotangent, hyperbolic cotangent of the natural log of x all over x. Or actually, plus, and I'm not going to have enough room here either. Or am I? I'll write it down here. So x hyperbolic cosecant natural log times, oh, I forgot to multiply this cotangent by that cotangent, so it's going to be negative hyperbolic cotangent squared natural log x all over x plus the derivative of the first function, a derivative of the second function times the first function. So I have negative hyperbolic cosecant squared times hyperbolic cosecant squared. So that's going to be, I can add the two exponents together. So this is going to be negative hyperbolic cosecant cubed of the natural log of x all over x minus high d low. So this is going to, derivative of x is 1. So this is going to be hyperbolic cosecant of the natural log times hyperbolic cotangent of the natural log all over x squared. So that's where I'm at now. Now let's clean this up a little bit. So if I distribute that x, you can say bye to these x's. And I'm left with what? I'm left with hyperbolic cosecant of natural log of x times hyperbolic cotangent squared of natural log of x minus hyperbolic cosecant cubed of the natural log of x minus hyperbolic cosecant natural log x times hyperbolic cotangent ln x all over x squared. I don't think there's any more simplifying that I can do, so I'm going to go ahead and say I am done here. With that, we will go ahead and call it a night. Cool. So yeah, we will go ahead and call it a night here. But before I go, I'm going to go ahead and I want to plug a few things. So first, as I said before, all of my lives are now up to tonight, not including tonight, but soon, are going to be uploaded here. And they're going to be uploaded to this channel. So if you do these 5 things, that would be amazing. Please show the last question again. Okay. And then the answer, because I didn't have enough space, is down at the bottom. So I'll go ahead and show that in a moment. And then, as I said before, here is a list of every subject I currently tutor. So I offer group tutoring and I offer one-on-one tutoring. So for group tutoring, I offer tutoring to groups of 3 to 10 students who are all taking the same subject at the same time. So, but it doesn't have to be with the same teacher or even at the same school. So for example, let's say you and 4 of your friends are all taking Calculus 3. Then, even if you're not taking it at the same school or with the same teacher, we can sign up for group tutoring. And then, so for that, I charge $35 per hour per person. And also, I also offer one-on-one tutoring. So if you're interested in either, please feel free to DM me and we'll set up a free consultation. Also, here are some things that I am currently working on as well. So I'm in the process of making a set of calculus flashcards. I'm going to probably start with limits or derivatives. Probably derivatives would be the easier thing to do. And then I'm also making a set of calculus tips and tricks. So I want it to be more than just something that you can find on the internet for that, just a list. I want to show you the tips and tricks that I use for calculus. And also, I'm in the process of working on a calculus notebook. So yeah, well, as soon as these 3 things are done, I will be uploading them to my TikTok shop. And then there are a couple other people here on TikTok that I recommend you follow. First is ACG Math Tutoring. So she's really awesome. Audrey was the one who actually convinced me to join TikTok. So if it weren't for her, I wouldn't be here. So if you're getting ready for your AccuPlacer, your ASVAB, your GED, your TEAS test, or if you just need a simple refresher in algebra or geometry, she is definitely the go-to person there. And also, I think she's live right now, but I also want you to follow Learning with Lynette. She's really awesome with the abacus. It's really fun, and like I said, I think she's live now. So as soon as we are done here, I'm going to be jumping into her live. So with that, what is a derivative? So the derivative tells the story of the slope. So the derivative tells us what the slope of a tangent line of a function is. So here was the answer to that last question. And I realized that this was actually the answer to another question that I wanted to give you. But hey, it is what it is. So yeah, with that, I'm going to go ahead and call it a night. Have a great night, everyone. And I will see you all tomorrow at 11:30 p.m. Eastern. Bye, everyone.